Hello friends, in the last lecture we have started new topic, that is biomolecules. We have seen the definition of biomolecules. Then we have started carbohydrates. We have studied the definition of carbohydrate, then classification of carbohydrate, that is monosaccharide, oligosaccharides and polysaccharide. Now we have started with monosaccharide, that is glucose. We have seen the methods of preparation of glucose, that is laboratory method of preparation of glucose from sucrose, and commercial, that is industrial method of preparation of glucose from starch. Now today we are going to start with the further part, that is next part, structure and properties of glucose. In the reduced syllabus there is no study of oligosaccharide and polysaccharide, so we are going to study only glucose molecule. Now, structure and properties of glucose. The first property is the molecular formula of glucose is C6H12O6. It contains 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms, and this molecular formula is determined on the basis of its chemical composition and colligative property. You must have seen already the colligative properties. There are 4 colligative properties, that is osmotic pressure, then elevation of boiling point, then melting point and vapor pressure. So on the basis of 4 colligative properties, the glucose has molecular formula, determined molecular formula is C6H12O6. This is the first property of glucose. Now second property, when this glucose is heated in the presence of hydroiodide or hydroiodic acid, N-hexane is formed, that is 6 molecules straight chain carbon atoms are formed, N-hexane, and this reaction shows that these 6 carbon atoms in glucose are arranged in the straight chain form, and therefore in the structure of glucose it is presumed that in the structure of glucose there are 6 carbon atoms arranged in the straight chain form. Now next property is, when glucose is reacted with hydroxylamine or hydrogen cyanide, it gives oxime, that is the CHO group is converted into CH double bond NOH, and when it is reacted with hydrogen cyanide, this aldehyde CHO group is converted into CHOH CN group. So by using this reaction it is determined that glucose contains carbonyl group, that is C double bond O group. We have already studied the reactions of aldehydes and ketones. So go through that reaction. When aldehyde is reacted with hydroxylamine or ketone is reacted with hydroxylamine, the carbonyl group is converted into oxime. Or when aldehyde or ketone is reacted with hydrogen cyanide, cyanohydrin is formed. The same reaction happens with glucose, and therefore by using this reaction we can say that glucose must contain at least one carbonyl group, that is C double bond O group. So by using these chemical reactions or properties, it is easy to determine the structure of glucose. In the first 2 reactions we have seen the molecular formula of glucose is C6H12O6. In the second reaction we have seen there are 6 carbon atoms arranged in the straight chain form. In the third reaction we can determine, or we can see that glucose contains one carbonyl group, that is C double bond group. Now in the next structure, or in the next property, when glucose is oxidized by using bromine water, this CHO group is converted into COH group. Bromine is a mild oxidizing agent, therefore it oxidizes this carbonyl group. It oxidizes only carbonyl group, and this CHO group is converted into COOH group, that is gluconic acid is formed. So by this reaction, we can say that glucose contains aldehyde, that is CHO group. This test is not positive for ketone. So in the previous reaction, we have seen the glucose contains carbonyl group. Carbonyl group compound, there are two carbonyl group compounds, that is aldehyde and ketone. But glucose contains aldehyde group, that is it contains C double bond OH structure. So by this property we can say that glucose contains aldehyde group, that is CHO group. Now in the next reaction, when glucose is reacted with acetic anhydride, this reaction we have seen in the alcohol chapter. When alcohol is reacted with acetic anhydride, the OH group is converted into acetate group. Similarly, when glucose is reacted with acetic anhydride, glucose pentaacetate is formed, that is 5-OCOCH3 group gets attached. By using this reaction, we can say that glucose molecule must contain 5-hydroxy group. Why it contains 5-hydroxy group? Because when it is reacted with acetic anhydride, pentaacetate is formed, glucose pentaacetate, as 5-acetate group get attached to glucose. Therefore, glucose must have 5-hydroxy groups in its structure. So, when glucose reacted with acetic anhydride, glucose pentaacetate is formed. Hence, glucose contains 5-OH group or 5-hydroxy group. Out of 5-hydroxy group, 4 hydroxy groups are secondary alcoholic group, whereas only one OH group is a primary alcoholic group. That is, you can see in the structure of glucose there is one CH2OH group. CH2OH is a primary alcoholic group. So to determine the primary alcoholic group, this is the reaction when glucose is reacted with, oxidized with nitric acid. Nitric acid is a strong oxidizing agent. Saccharic acid is formed. The structure of saccharic acid is COH, CHOH 4 times, and again third part is COH. Hence glucose contains only one primary alcoholic group, that is CH2OH group. Go through this reaction. It is the reaction of aldehydes and ketone. What are the product of reaction when acetone is reacted with hydroxylamine, or when acetaldehyde is reacted with hydrogen cyanide, or when ethyl alcohol is reacted with acetic anhydride. We have already seen this reaction. So go through this reaction, then you can easily understand the reactions of glucose also. So by these 6 properties, Emily Fisher, which get Nobel Prize in year 1902 for her study on glucose. So Fisher gave the first formula of glucose. You can see here in the first structure there is one CHO group, then 4 CHOH group. Out of 4 CHOH group, the third carbon atom contains OH group at left side and hydrogen at the right side, whereas second, fourth and fifth carbon contains hydrogen on the left side and OH group on the right side. First carbon is it forms CH group, that is aldehyde group, and sixth carbon is primary alcoholic group, that is CH2OH group. So this is called Fischer's projection formula of glucose. Similarly, the structure of gluconic acid is COH. Instead of CHO, it is converted into COH group. Gluconic acid is formed. The remaining part is same. Out of this 6 carbon atom, carbon number 2, 3, and 4 and 5, it is not shown in the structure, but it is assumed that there are in every cross there is one carbon atom and there is a star on each carbon atom. That means there are 4 asymmetric carbon atoms. Due to 4 asymmetric carbon atom, glucose molecule or this gluconic acid or saccharic acid, all these molecules they contains 4 asymmetric carbon atom, therefore they are stereoisomers. They shows optical isomerism. In the structure of saccharic acid, you can see the first carbon is COH group and 6th carbon is also COH group. But the remaining part, that is carbon number 2, 3, 4 and 5, they are same as of glucose. In the third carbon, OH group on the left side and hydrogen on the right side, whereas carbon number 2, 4 and 5, it contains hydrogen on the left side and OH on the right side. So this is the structure and properties of glucose. In the next lecture, we will see the detailed structure of glucose.